All right. All right. So first of all, this big thing, this is a Greek letter. All right. Earlier in the year, we had this guy. That was theta, right? That's a Greek letter also. So in math, we use Greek symbols because eventually we run out of letters to use. Right? There's so much stuff going on. This is a Greek symbol, and its name is sigma. Not to be confused with the basketball sigma. Sigma, Jack Sigma, the sigma move where you reverse pivot and all that fun stuff. Be at 10. Well, it's a sigma. All right. Sigma just means sum. It just means we're going to add some things up, right? Which is what we did last class. We did a series, right? That's what a series was. We had a sequence, which was just a list, like numbers like 1, 2, 3, right? That's a sequence. What happens when I change the commas to plus? What's that called? This is a sequence. This is a series. It's also a sum. So when we see this, this is just saying sigma is a short way of saying add up all this stuff. Okay? If you look on Microsoft Excel, there's a function called AutoSum. You guys know what I'm talking about? Anybody in the world? Okay.
Yeah,
anyway, this is the button. That's what it looks like. Okay? Yeah, it adds them up. So what are we going to add up? Well, we're going to add up. First of all, we need to figure out what number is going to be there. So what we're going to do is we're going to start with this number. This is your starting point. So write down your sigma. This is your starting point. You start with 1.
We start with whatever number is right there.
Whatever number is right there. We're going to plug that number in. Okay, so if we plug that in, we get 2. Yeah? And then we just go up to the next term in the sequence. So the next term after the first term would be the second term, right? Okay, so now we keep going up. So this is number we plugged in. We started with 1. Okay, now we're going to plug in 2. And we get 1, right? And what are we going to do with these? We're going to add them. Now, this is why this is easy. This is the last one. So this is the end. This is the last number we're going to plug in. So in this example, they're saying, hey, start with 1, end with 2. So we're only plugging in 2 numbers. We plugged in 1, we plugged in 2. Deal? If this had a 20 here, we'd start with 1. Then we plug in 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. We'd stop, and then we'd add everything up.
But you just directly plug that in for K. Like,
yes.
So you just put 3 minus 17 is negative 4.
Yep. There we go. So like the last number, if it was 20, would be we plug in 20, right? 3 minus 20 would be negative 17. Then we'd add up everything. Okay? So in this case, there's only 2 things to add up. That's our answer. So like I said, it looks very creepy and spooky. My kid needs to stop watching Halloween videos on YouTube, kids. It's like all he watches. It's weird. Anyway, what are we going to start here? This one. Yep, it's 3. Just 2 plus 1. What are we going to do? We're going to plug in 1. This is the first thing we're going to do. 1 minus 1, which is, and then we're going to go to the next number, which is 2. The last number is going to be 3. Okay? We have to do all the whole numbers in between, though. So 2 minus 1 is the next number, which is, and then the very last number we're going to do is 3. And then we're going to stop. 3 minus 1, which is 2. What are we going to do with all of them? Add them up. So our answer is 3. Oh, all the answers must be 3. Classic human brain pattern recognition, even though it's not a pattern, it's just 2 things. Right? All right, so all of those are going to look something like that, as you can tell. If it's like this, it's just saying Plug in 1, take it times 3, right? Do whatever the formula says to do. Plug in a number, it spits out an answer. Add up all of them. Okay, all of them are pretty low in total things you're going to plug in. It's not going to ask you to plug in like 15 things or anything like that. All right, so that's first assignment. The next one is a lot like what we did the other day. We're going to use the same formula. And if you don't have that formula pulled up, how dare you? First of all, but secondly, look for it in your notebook. It is the sum of a geometric series. It's the one on the whiteboard right over there. You remember this thing? It's that deal. Okay. This is equal to the sum of the first certain number of terms. It says find the sum of the geometric series, and that's what we're doing. So tell me right now, what's the first term in the sequence? Let's fill in all of these right now. The first term is 1. That is correct. Tell me the common ratio, the R. What are they doing? What are they multiplying by? They don't, it's not as easy to tell on this one. It is 0.8. Yeah, you're right. Why is it 0.8? You have a new exponent, right? So if you're adding an exponent, when you add exponents, you're actually doing what? Well, multiplying, right? Not necessarily doubling. You mean you're putting it on one more time, right? So it's like 0.8 another time. How many terms are there? This is something I want you to think before you say it out loud. Oh, dang it. Try again. So think about this. If this is 19, this is 1, right? So 1, 2, 3, 4, 19. How many total terms, though? 20. Yeah. Oh, the 1 does count. So you have 1 through 19. That's 19, right? 1, 2, 3, 4. You count all the way to 19. That's 19 items. Here are 19 things in the list, right? And then the first one. There are 20 total terms. So this gets a little funky like that. It makes you think there's only 19, but there's 20. So we're going to do this the same way we did the other day. Make sure if R is negative, make sure you use parentheses around it. You don't need to now, though, because it's a positive number. But let's go ahead and compute this. We're multiplying by 1, so I won't do that like I normally did, right? I'll do that last if it was, but not in this case. So let's do 1 minus 0.8 to the 20th. What's the bottom? Yeah, let's simplify that in our brains right now. So that's 0.2. So I'm going to divide by 0.2. Make sure you can get this answer on your calculator. 4.94. Bingo. There it is. Make sure you can get that on your calculator. That one's 4.94. Okay, so this one is the same idea. Tell me about this one. This will be the last one. It's multiplying by a -3. Aha, at last. Here we go. So we need our first term. We need the common ratio, and I'm going to fill in all these again, just like I did a second ago. What's the first term? Yep, there we go. Times 1 minus -3. What did I say to do if it was negative? Yeah, use parentheses. And then how many terms are there? Yeah, no tricks on this one. It just tells us there's 45 of them. Please remember, this part on the bottom as well. What happens there? Take a look at the bottom of that fraction. What's that going to be? That's 4. It's not -2, right? A lot of people mix that up. So let's go ahead and compute this. It's the same formula we used the other day, so it's not really a new task. So 1 minus -3 to the 45th. You see that number?
What is that even called?
Okay, let's see. 100 million, so million, billion, trillion, quadrillion, quintillion, hexillion. That's what that is.
2 hexillion.
2 hexillion. 2.95 hexillion. Yeah. All right. Now we've got that divided by what number? What's the bottom? 4. Yep. And then times 0.5, but negative. Oh, shoot. Dang it. I got to do all that again.
I don't remember that number.
Shoot. To the 45th divided by 4 times 0.5 negativo. That number. Okay, so let's look through our choices. It's going to be represented in scientific notation. Yeah, there it is. Right there. What's this mean, though? -3.69.
That's 4 places to the right.
Right. All right. This means -369 and then 20 zeros. Right? Ish. As a rounded decimal. All right, let's stop there.